Mechanical advantage, velocity ratio, efficiency of a machine, and ways of maintaining machines. Scientists have a way of knowing if a machine is worth having, and there's no point constructing a machine which is not efficient. The work done on the load by the machine must be greater than the work done on the machine by the load. When we compare the ratio of the effort applied to the machine to the work done by the machine, it is referred to as mechanical advantage. Mechanical advantage is defined as the ratio of the load to the effort applied to a machine. And if this ratio is greater than 1, the machine is said to have a mechanical advantage. But if this ratio is less than 1, the machine is said to have a mechanical disadvantage. I say again that mechanical advantage is defined as the ratio of the load to the effort applied in a machine. And if this ratio is greater than 1, it is termed mechanical advantage. And if the ratio is less than 1, it is referred to as a mechanical disadvantage. Now, if the mechanical advantage of a machine is greater than 1, it means that the machine can overcome a greater load than the applied effort. And if the MA, mechanical advantage, is equal to 1, it's an indication that the load is equal to the applied effort. And if the mechanical advantage is less than 1, we have a mechanical disadvantage. It means that the applied effort is greater than the load done by the machine. Example, if a force of 80 Newton is used to overcome a load of 240 Newton in a machine, what would be the mechanical advantage of that machine? To get your mechanical advantage, you use a simple formula, which is your MA, mechanical advantage, is equal to the load over the effort. From our question, we're given the load to be 240 Newton, while the effort to be 80 Newton. If we divide 240 by 80, you get 3. And note that there's no unit for mechanical advantage because the 2 Newton in the variables will cancel out, leaving only 3 as the answer. So therefore, the ratio of load to effort in any machine is termed mechanical advantage. Again, the ratio of load to effort in any simple machine or complex machine is termed mechanical advantage. And if this ratio is greater than 1, it is a mechanical advantage. But if the ratio is less than 1, it's a mechanical disadvantage. It means that much effort is applied to do a little work. It is termed a mechanical disadvantage. Next, we'll look at velocity ratio. It is the ratio of the distance moved by the effort in the machine to the distance moved by the load at the same time. VR is the ratio of the distance moved by the effort in the machine to the distance moved by the load in the machine. Next is the efficiency of a machine. Efficiency of a machine is a percentage of useful work done by a machine to the force or energy supplied to do the work on the machine. Mathematically, efficiency of a machine is equal to the work output over the work input times 100 over 1. Efficiency is equal to the work output in the machine over the work input in the machine times 100 over 1, which means that the MA, which is the mechanical advantage, also refers to as the work output over the VR, which is the work input, times 100 over 1, will give us our efficiency of the machine. But in practical sense, a perfect machine has 100 efficiency, which means that all the work done by the effort is used to overcome the load on the machine. For a perfect machine, the mechanical advantage must be equal to the velocity ratio. But in practical sense, this is not achievable due to friction. Now, friction is the force that opposes the motion of moving parts of machine. So due to friction, no machine is 100% efficient. Again, due to friction in the moving parts of a machine, no machine is 100% efficient. Some of the parts in a machine may be very old and inefficient, and as such, some of the energy inputs will be converted into noise and some into heat, leading to incomplete combustion taking place in the engine. Therefore, there is no perfect machines due to friction. There's no perfect machine due to friction in the moving parts of the machine. Next, we'll look at care and maintenance of machines. Care and maintenance of machines. Now, machines are very important and need to be serviced regularly. To reduce the rate at which these machines break down, we need to service machines regularly. Maintenance means the special care given to machines and other facilities so that they can be in good working conditions and last long. Again, maintenance is defined as the special care given to machines and other facilities so that they will be in good working conditions and last long. And this can be achieved through the following means: lubricating of the metal part of the machine. Lubricating the metal part of a machine can help to reduce friction, thereby avoiding the wearing and tearing of the parts of the machine. Therefore, lubricating the metal part of the machine is a means to maintain machine. 2. Regular cleaning of the carburetor of a machine will help to prevent dirt from blocking the jets for petrol. Gauge oil regularly to prevent heating up and damaging of machine. Gauge oil regularly to prevent heating up and damaging of the machine. Checking and warming up the machine regularly. The use of ball bearings. The use of ball bearings in moving parts of a machine can also help to reduce frictions. The use of ball bearings in the moving parts of the machine can also help to reduce friction. Regular changing of oil makes the engine to last long. And also, machines can be painted. Machines can be painted to prevent corrosion or rusting of exposed parts of the machine. Machines can be painted to prevent rusting or corrosion of exposed part of the machine. And machines should be kept properly in the right place after usage. Mechanical advantage, velocity ratio, and efficiency these are terms that describe the workability of a machine. Mechanical advantage is the ratio of the load to the effort, while velocity ratio is a distance moved by the effort to the distance moved by the load at the same time in the machine. Why no machine is 100% efficient. No machine is 100% efficient due to friction in the moving parts of machine. And machines need to be maintained regularly to ensure that they'll be in good working conditions. And this can be achieved by lubricating the metal part of the machine, regular checking of the oil, and also The use of ball bearings to prevent friction in the moving parts of the machine.